Hey there, in this video we're going to look at one of the methods that we can use to solve polynomial equations, and specifically quadratic trinomial equations. So quadratic are equations where the highest exponent is x squared. Quadratic refers to like a quadrilateral, a four-sided shape, like a square. So that word quadratic in mathematics means squared. And trinomial means we have a polynomial with three terms. So in a quadratic trinomial, we will have three coefficients. The coefficients are the numbers that are in front of the variables in each term. And we can label these coefficients A, B, and C. We have x squared as our first term. So the reason I've said that a is equal to 1 is because another way we can think of x squared is that's like 1x squared. And today we're just going to look at factoring in the case that our leading coefficient, a, is equal to 1. If a is not equal to 1, then we can use a similar method as what we're going to see here, but with some slight modifications. But so in the case that a is equal to 1, the next thing we want to do is set up a little number puzzle for ourselves to solve. We want to find a pair of numbers that when we multiply them together equals this last coefficient, c, and when we add them together equals this coefficient in the middle, b. So there are a lot of different ways that we could write this when we're setting it up, but here's one way that I like. We're going to make a little diamond here for ourselves, and the two numbers that we pick need to multiply together to give us this number on the top and add together to give us this number on the bottom. Now you might be able to see right away a pair of numbers that works, but if you get stuck, I would recommend you start by thinking about the multiplication part, because there are infinitely many ways we could add two numbers together to get 11, but there's a relatively smaller number of ways that we can multiply two numbers to get 24. So when I get stuck trying to solve these types of puzzles, I'll start by listing the factors of the number we're trying to multiply to get. So the possible pairs of numbers that we could multiply to get 24 is 1 times 24, 2 times 12, 3 times 8, 4 times 6. And it looks like that's actually all of our factors. I know we're done with our list here because if we keep trying to go bigger, well, 5 is not a factor of 24, and then we get back to 6, but we've already seen 6 times 4. Now that we've got this list of possible factors, it's easier for us to see which option works. To add two numbers together and get 11, we're going to have to use 3 and 8. So that's the pair of numbers that solves the puzzle we set up for ourselves in step 1. Now we're going to factor this polynomial. So we're going to take the original equation that we had and split it apart into two factors. And the way that our factors will look is x plus one of the numbers that we found times x plus the other number that we found. And those numbers are what we got from our puzzle in step 1. So we're going to take this entire equation that we have here and split up the polynomial on the left to rewrite it as x plus 3 times x plus 8. And this equation is still all equal to 0. Now it's important to note that we haven't changed the value of this equation. All we've done is rewrite it by splitting it up into two simpler things. Just like we could take for example, the number 20, and we could rewrite it as two smaller numbers, 4 times 5. That's what we've done here. We took this trinomial and we broke it apart into two smaller polynomials. But if you want to make sure that this actually works, I recommend you actually work through the multiplication here and multiply all of these terms together, and you will see that we get back to that original polynomial we had. So that step 2 that we just did, that takes care of the factoring. And if we're trying to solve an equation, meaning figure out what x equals, well, then there's just one more step that we need to do. This works only in the case that one side of our equation is equal to 0. There's a special property of 0 which says that if we have two things multiplied together and it's equal to 0, well, one of those two things, or perhaps both, has to equal 0. So to figure out the value of x that makes this all equal to 0, we want to set these factors equal to 0 and then solve for x. So one possibility is maybe this first factor, x plus 3, is equal to 0. If x plus 3 is equal to 0, then to solve this, that means we want to figure out what value of x makes this true. And we can subtract 3 from both sides of this equation to isolate our variable x, and we would get x equals -3. So that's one of our possible answers. If we set this other factor equal to 0 and solve for x, then another possible answer is x could equal -8. So there's a distinction here between what I have written in red and what we have written in purple. The parts in red here, these are the factors of our polynomial that we got by splitting it apart. And what we have in purple here are the solutions to this polynomial equation that would make it equal to 0. And notice there's a very clear relationship between the factors and the solutions. They're almost the same numbers, just with the signs reversed because of what we did when we set these equal to 0 and solved. So that's a pretty quick method, but be aware that the way we've written it out here is just in the case that a is equal to 1. If that leading coefficient a is something other than 1, we're going to need to modify this slightly. But let's do another example with a trinomial where a is equal to 1. Alrighty, here's another example for us to try out. So this is a quadratic trinomial because the biggest exponent is squared and it has 3 terms. So we can find our 3 coefficients, a, b, and when we see a negative in front of x, that really represents the coefficient -1. So b is equal to -1, and we have c equal to -30. Because a is equal to +1, we can use this shortcut method here and just worry about the coefficients b and c. So we need to find a pair of numbers that will solve this puzzle for us. Something times something is -30, and that same pair of numbers added together equals -1. So if we're trying to multiply to get a negative number, we know that we're going to need to do a positive number times a negative number. And if the number we get when we add together is still a negative, then that means that the negative factor needs to be bigger than the positive factor. Now let's list the possible factors of 30, and then from that list, we can pick the one that works to add up to -1. Now you might already see the pair of numbers that works right away, but when I get stuck on these, it's helpful to list out possible factors. So we have 1 times 30, 2 times 15, 3 times 10, or 5 times 6. Now the only option that would work to add and get -1 is if we do 5 and 6, and if we want to get a -1, then we need to have +5 and -6, so that when we add those together, it is negative. Now that we've found a pair of numbers that solves our puzzle, let's split our trinomial apart into two factors, x plus 5 times x minus 6. And this equation is still equal to 0. So those are the factors of our polynomial. And sometimes we're not always trying to solve an equation, figure out what x equals. In certain expressions, it's helpful just if we're able to factor something. So you might be, for example, if you're trying to simplify a fraction that has polynomials, you don't always need to do this last step and solve if you're only trying to factor. But in this case, since we are trying to solve this equation, figure out what makes this equal to 0, we need to set each of these factors equal to 0 and solve for x to get two possible solutions. If we subtract 5 from both sides of this equation on the left, we'll get x is equal to -5. And to solve this equation on the right, we can add 6 to both sides, and we'll get x is equal to +6. So when this method works, if we are able to solve that number puzzle and find those two factors, this is probably the fastest way to solve a quadratic trinomial. But I also want to mention that not every equation can be split up by factoring. There are certain equations where we'd have to use a more powerful technique like the quadratic formula. So if you're feeling comfortable with this and you want to start practicing, I encourage you to go ahead. If you want to stick around and look at one more example, let's try out another one. Or you could also pause the video after I write this down, try to work through it yourself, and then continue the video and we can check your answer together. So we have our leading coefficient a is equal to 1, b is equal to -7, and c is equal to +6. And remember that the steps that we've seen in this video are applicable just if a is equal to 1. So this will work out for us in this case, and the puzzle we're trying to solve is two numbers that will multiply together to equal 6. So the possible factors we could try are 1 times 6 or 2 times 3, and we also need these numbers to add together to equal -7. Well, how can we multiply to get a positive, but when we add, it's a negative? We can remember that a negative number times a negative number is a positive number, and a negative number plus a negative number is still a negative number. So in this case, two negatives are what's going to solve our puzzle. And if we add -1 plus -6, that gets us -7. So we can split this trinomial up into a pair of factors, x minus 1 times x minus 6 is equal to 0. Those are the factors of this polynomial, what we just wrote in red, and now in purple here, I'll find the solutions. If we set each of those factors equal to 0 and solve for x, on the left, one of our answers is x equals +1, and on the right, our other answer would be x is equal to +6. Now, if we're trying to factor or solve trinomials where a is not equal to 1, that this symbol here, the equal sign with a line through it, that means not equal to 1. So if a isn't 1, then we're going to follow a similar method, but with some slight modifications. So I'll put that up in another video if you want to check that out.